Let's begin. Today's December 12th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 9, 12, 16, 19, 20, and 22. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our 3-digit solution, and the Turing Machine will let us know how many 3s there are. Are there no 3s? Is there a single 3? Perhaps 2, maybe even all 3 are 3. Criteria card B will take a look at our first and last digits, the triangle and circle, and compare them. Should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card C, again, we'll take a look at our 3-digit solution, but this time the Turing Machine will let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card D will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Criteria card E again takes a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. One possibility is that there are no repetitions, as in the example 125, or it could be a double number, where a digit is repeated, as in the example 112, or the solution could actually be a triple number, where it's a single digit repeated 3 times, as in the example 222. And finally, criteria card F again takes a look at our 3 digits from triangle to square to circle, but this time the Turing Machine will let us know a little bit about the ordering of the digits. Should the digits appear in an ascending order, meaning that they are increasing, as in the example 135? Should the digits appear in a descending order, or basically decreasing, as in the example 421? Or possibly the 3-digit code could have no order. So let's take a look at the example 231. Notice that it goes from 2 to 3, it increases, but then it goes from 3 to 1, then decreasing. Of course, you could have a code that's decreasing and then increasing, but basically it's that shift from one direction to the other that is one way to define a 3-digit code as having no order. We have seen also in other puzzles where if you have consecutive equal digits, that can exhibit no order. So for example, if we come back here and view this example of 112, notice that the ones are consecutive and they're equal. But as I stated, the reason that this exhibits no order is because when you go from 1 to 1, that neither increases nor decreases. And so that breaks the ascending and descending quality. So again, for that reason, if you have consecutive equal digits, that is another way that a 3-digit code can exhibit no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card C. Okay, so the Turing Machine does not approve of my proposal. Notice that I do have 2 odds to a single even, but since the Turing Machine does not agree with that, it's actually informing us that there should actually be more even than odds. So let's go ahead and type that up in our notes in section C. And again, we'll say that there are more even than odds. So what does that mean? Well, at a minimum, we must have two evens and potentially an odd, or the solution could be an all even solution. So two evens and an odd, or an all even solution. The next thing I think I'd like to test is criteria card D. Okay, so again, the Turing Machine does not approve of my choice. Notice that if I add 3 and 1, that gives me a total of 4. 4 is less than 6, but since the Turing Machine does not agree with that, that means that the sum of the first two must either be equal to 6 or be greater than 6. So let's go ahead and type that up in our notes in section D. And that again is that triangle plus square must be either equal to 6 or be greater than 6. Okay, so we do have at least two evens, and it could be that triangle and square could be, a 2 and a 4 in some order that add up to 6. That's a possibility. But I don't think we can actually cross out anything at this point. The only thing we can just say is that between triangle and square, you can't have two small digits. Like, for example, it can't be a 1 or 2 in some order, because, that sum is less than 6. And actually, if there is to be a 1, it would have to be paired up with a 5, because at least that does make a 6 total. So if we have a 1, it must be a 5. Otherwise, there could be some other kind of combination. But I don't think we can cross out anything at this point. Let's see what else. I think let's go ahead and test criteria card B. Okay, so again, the Turing Machine does not agree with my choice of triangle and circle. We can say that if you notice, my triangle value 3 is smaller than my circle value. So that is not true based on what the Turing Machine just responded. So either triangle should be equal to circle, or triangle should be greater than circle. So let's go ahead and type that up in our notes in section B, and we'll say that triangle should be either equal to or be greater than circle. And so let's see, can we say anything about that? Well, the fact that they can be equal is hard to really cancel anything, because they're equal. It could be 5-5, but it could easily be 5-4, where the triangle value is greater. So again, I don't think we can cross out anything at this point. Hard to believe, but yeah, that's the case. Okay, yeah, just trying to review these possibilities. Okay, well, that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not query criteria card A, identifying how many 3s. Well, at this point, because we know we have you know, maybe an odd. The most it could be is either 1 or none. Obviously, you can't have 2 and you can't have 3. So either the 3 is there or it's not. And just to add a little bit to that, just because a 3 may not be present doesn't mean that it's an all even solution. It could be a 1 or a 5. We just don't know. We also still have criteria card B outstanding. We don't know if they're equal. And let's see what else. And then we didn't test, whether there's any repetition or a double or a triple. And we also did not test criteria card F, the ordering. Now, I will say that having played some of these puzzles in the past, there's a reason I did not test E and F, and that is because in prior videos I demonstrate how each one plays against each other, where we can actually deduce what they are. So, for example, if I were to say that, let's presume that the order of the 3-digit solution is ascending. Well, when it's ascending, that means that they are all uniquely getting larger. So you can't have any equal digits at all. So if it's ascending, you would know that the 3-digit solution would have no repetitions because of that. Well, if that's the case, then this card, criteria card E, would be irrelevant. Because again, if it's ascending, they're all distinct. So for that fact, the 3-digit solution cannot be ascending. And a similar argument could be said if the 3-digit solution is descending. Well, again, they are decreasing, but again, they are uniquely descending. There are no duplicates. So again, no repetitions would make this card irrelevant. So for that fact, we can actually make the argument that we can deduce that the solution must have no order. Because again, if we make the argument that they are ascending or descending, we know that there would be no repetitions. Well, we can similarly use criteria card E in a similar fashion and say, well, if a 3-digit code is a triple number, well, by definition, that has no order because, as I stated at the top of the video, if you have consecutive equal digits, then there's no order. So, as in the example 222, if you go from 2 to 2, or whatever the digit may be, there's no change. So that would mean that if you have a triple number, that by definition, it has no order. And then if it's a double, again, similar argument. If you have consecutive equal digits, that has no order because when you go from 1 to 1, there is no order. And, and even if they're not consecutive, if you have a pair separated by that middle digit, I don't see an example of it here. Yeah, I don't see, but if it will say 1 2 1, well, 1 2 1 has no order because it increases then decreases. And that can you can make the argument of any pair of digits that would be triangle and circle and the middle being different. So yeah, if you have a double number, that has no order. So then we can deduce that the solution must have no repetitions. So again, we can deduce the solution has no repetitions. So that means we can say that, they're going to be all unique and have no order. Well, for that fact then, because there are no repetitions, that means we can actually deduce that triangle and circle cannot be equal. because again, we just stated that they are all unique. So let's go ahead and, well, I'll just add an added note here that we're going to deduce. We are deducing that triangle must be greater than circle. Okay, now because of that, we can cross out some possibilities. Since triangle is to be greater, that means triangle cannot be a 1, because if triangle were 1, there's nothing smaller for circle to be. And similarly, circle cannot be a 5, because if circle were 5, there's nothing triangle, that triangle could be, how can I state this? Circle cannot be 5 because there's nothing greater for triangle to be. So now we can cross out those possibilities. Let's see, what else? Okay, so it's still outstanding whether the sum is 6. We do have 2 evens. Well, okay, so because of the no repetitions, now we can state here that no repetitions and we have evens, then it is going to be a 2, a 4, and an odd. So we know we can't have a pair of 2s or a pair of 4s. So we are looking at 2, 4, and an odd. And again, we do have criteria card A, where that odd could be a 3, but if it's not, it's going to be a 1 or a 5. Let's see what else. Okay. Well, let's talk about, can the sum of the first 2 be 6? So if they are 6, it's going to be 2 and 4 in some order. And, well, let's see. It would be interesting if there is a 3 and if the sum is 6. Well, that would force circle to be a 3, right? If the sum is 6, let's see, what can we, yeah, you can't have a sum of 6 with 1 and 5 or 3s because of the, having 2 evens and no duplicates. So yeah, you would have to have 2 and 4 in some order. And if you did have a 3, then that would mean that triangle needing to be bigger than circle would be 4, 2, 3. Again, that's if the sum is 6. Let's see, can we make any other kind of argument here? Just trying to think of the sum being equal to 6 or greater than 6. Well, let's see. If the sum, yeah, I'm trying to see if we can cross out any additional numbers. I'm having a hard time thinking of that. Well, let's go with that sum of 6, and I'm going to say that there is going to be a 3, so that would force circle to be a 3, and because triangle has to be bigger, I'm going to say it's 4, 2, 3. Yeah, let's go with that. Let's see if that's true. 4, 2, 3. So just to review, yes, our first digit is bigger than circle. Triangle is bigger than circle. Yeah, 4 is bigger than 3. I'm presuming that the sum is 6, so that's still good. I do have a 2 and a 4 and an odd, and I'm saying that there's going to be a single 3. Okay, so let's go ahead and try that out. And so we've already, again, outright deduced E and F. I guess I should have said, yeah, there are no repetitions. Well, that's true, no repetitions. And it is no order, right? Because 4 to 2 is decreasing, and then 2 to 3 is increasing, and that has no order. So yeah, so we've outright deduced E and F. So it comes down to A, and then I guess to some extent D, because B and C are already well established. So let's go ahead, let's test let's go ahead and test D to see if the sum is 6. Okay, yeah, so the sum is 6. So let's go ahead and update our notes in section D. It's not greater than, it is in fact equal to 6. And as I mentioned before, it must be even. The first two must be even, because there's no way you can add 2 odds to get a sum of 6, because of there needing to be more even than odds. So that means that there are no odds in triangle and square. So we can cross out all of the odds. Okay. And that would mean that circle has to be an odd. So we can go ahead and cross out the 2 and the 4, because again, you can't have any duplicates. We've already established the first 2 being even. And let's see, we've also stated that triangle has to be greater than circle. Can we cross out anything there? Well, 4 is greater than 1 and 3. And I guess technically you can say 2 is greater than 1. Let's see, what can we say? Can we say that, can we deduce that there is a 3 or not? I don't know if we can make that argument, because I guess, let's see, if circle were to be a 1, would you have ambiguous solutions? If there is a 1, say there is no 3, that would force it to be a 1. I think you would have ambiguous solutions, because you could have it be 2, 4, 1. But there's also no order. So let's see. Could you have 4? I don't think. Well, you can't have it be 4, 2, 1 because of the no order. But that just would mean that it would be 4, 2, 3. Okay. So no order tells us it has to be 4, 2, 3. And in that case, yes, it's true. 4 is greater than 3. Could it be 2, 4, 1? Yeah, it could be 2, 4, 1. Could be 2, 4, 1. So I think, yeah, 4, 2, 3 and 2, 4, 1. Yeah, those are both viable possibilities. And so that informing us whether there's a 1 or a 3 would inform us which one to pick. And so, yeah, let's go ahead and pick criteria card A, because, we don't know. It could be either or, and that would inform us. Okay, so let's go ahead and pick test criteria card A to see if there's a 3 or not. Okay, so the Turing Machine does not approve of the presence of a 3. It doesn't like the fact that there is a single 3. So that means that we can, let's see, how would we phrase this? We would have to say that there are no, wait, hold on. Yeah, it doesn't like the fact that there's a 3. So there, in fact, should be 0 3s. So I think we're going to say we're going to deduce the solution has no 3-digit. Is that right? Is that what that means? Yeah, it doesn't like the fact that there is a 3, so there should be no 3s. So let's go ahead and cross out the 3. And yeah, it doesn't like the fact that there is a 3 in my proposal. So yeah, so we're going to deduce a solution has no 3-digit. And because of that, that forces triangle to be a 2, because if triangle were 4, then it would be 4 2 1, meaning that it's descending, but it should have no order. So that means that it forces triangle to be a 2, and then it would force square to be a 4. And so it looks like our solution is 2 4 1. So let's go ahead and type it. And let's go ahead and review. So again, it did not like the fact that there was a 3 in my code, forcing us to say that there should be no 3. So yeah, and there is no 3. It is true that triangle is bigger than circle. Our first is bigger than our last. Yes. We do have a 2 and a 4 and an odd. There's a majority of evens. The sum is 6. It is true. 2 plus 4 is 6. There are no repetitions, and there is no order. Yeah, it increases, then decreases. Wow, well, this has been a bit of a whirlwind, but I think we've got it. Okay. Yeah, I didn't like the fact that there was a 3. I don't know why this is giving me some pause, but yeah, that's the way to interpret it. Didn't like the fact that there was a 3. Okay, well, let's go ahead and verify 2 4 1 as a solution. So 2 4 1, and let's see if the Turing Machine agrees. Okay, yes. Well, how do we do versus a Turing Machine? Well, it is a 6 criteria card puzzle, but because of our deductions, we only had to test 5 of them, or do 5 tests. We did have to repeat D just to confirm that sum of 6. So we did B, C, D all incorrect, and then we did A, D, where D, yeah, we got the sum of 6 to be, we confirmed that the sum should be 6. And so let's go ahead and type that up. So B, C, D in the first round, all incorrect, B, C, D. And then in the second round, we got A incorrect, and we did confirm that the sum is 6. And outright deduced DF, we didn't have to test those at all. Okay, wow, so we obviously did beat the Turing Machine, but only by 1 question. That is a bit surprising, just because, we outright deduced these 2 criteria cards. I would have thought we would have, won by 2. So somehow it's saying that maybe we didn't have to test D. It could have been that maybe it was obvious that the sum had to be 6. Perhaps maybe there were too many possibilities where there would be ambiguous solutions, where if it wasn't 6, perhaps, I'm not sure. What about you? Did you find any additional efficiencies in your choice in criteria cards? How did you solve it? What criteria cards did you choose? And did you find anything interesting that you'd like to share? Well, add those thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.